Hey fellow R programmers, welcome to another session of social informatics that according to the schedule you have noticed today we are working on R. The specific topic we are doing today is loops, and we'll start with this, that what is a loop? In computer programming, a loop is a sequence of instructions that is continually repeated until a certain condition is reached. So, loops save energy for us in typing the code. For example, assume you want to repeat a task for 1,000 times. Of course, it is not wise to write that piece of code or that statement you want to be repeated 1,000 times in your code. In this way, you have this statement and you repeat this statement for 1,000 times. And it is called loop. Loops are in every programming languages. They are inseparable part of programming. Here you see a schematic presentation of loop. It starts from here, and first it checks condition, because if we don't put conditions on loops, they would repeat themselves infinite times. And in fact, our program will crash because it will continue infinitely or indefinitely. So you need condition to check if, in fact, so the computer checks if it should do it for another time. If yes, the condition holds, okay, the loop body is performed. And after that, again, the story. It continues until the time that the condition is not holding anymore. That's the end of the loop. We quickly gonna start some examples with R so you will understand this much better. Here, as an introduction, I have put for you three similar but slightly different structures to do for loop in R. The size of loops that you see here, for example, for the first one is 10, for this one is 3, 1, 2, 3, and for this one is 6. Okay, but you can make it billion. About this one, it is a for loop. So the syntax is like this. We are going to practice many examples with this one until you get it well, especially because it is the first loop we are learning together. So it says for, open parentheses, close parentheses. Here it says for x in 1 to 10. So this 1 to 10 means 1, 2, 3, 4, and like that it continues until 10. So it says for x in this print. I'm gonna now run it for you in R, but just if we want to run it manually, see what's happening here. It says that for x in this range, so it means that this is gonna be x, this is gonna be x, this is gonna be x, this is gonna be x. So you see the repetition. And what is the statement it wants us to run? Printing it. The next one, we don't have a range like this. We have a list, fruits list, and we have a string inside them, exactly based on the same logic for x in fruits, that is this one. So X one time is gonna be apple, X one time is gonna be banana, X gonna be cherry, and it says print it. The next one, we don't have range, we don't have list, we have a vector. And again, the same story for X in the vector, print them. Now let's go and do this thing in R to learn them better. Okay, let's start with the first syntax. Mostly when you want to put the condition for even in all the programming languages, you put them in a parentheses. But when you want to put statements, you put them in curly brackets. Now you will see it here for X in 1 to 10. And you remember, we talk about the things a lot, my friend. So you can define the range any way you like, with the steps, with the details that we have discussed before. But since now our focus is on loops, and specifically here for loops, I'm just going to show you about for loops. So I want to put this statement, so I put the curly brackets here, and I can put anything here that I want to be repeated according to these things that we see here. So I'm gonna put print X. And when I run it, you can see the results here. 1, 2, 3, 4 until 10. One thing that you may say that, what if you want to repeat doing something for 10 times and not getting the value of the counter that we have over there? Of course you can do that. For example, you want to print hello world 10 times, for example. Okay, you see I'm stating that for X in this range, print hello world. So we have this, and I run it. And we get this result. For the next one, if you remember, it was a list and with some names of fruits inside it. So let's go for that. And you please also doing the things even ahead of me. And for X in, and here I'm gonna put the list. Apple, orange, apple, cherry. And now since I want to put the commands, I put the curly brackets and I put print X. What happens? It goes and for each value of X inside this, it runs the statement. We can make many sophisticated codes that, as much as time allows us, we are gonna do some examples, but the concept is that much simple. And here, when I run it, I get this result. You see, it prints all of them. The same as the one in the above. If you put print a hello world here, it would print hello world, the same number of the size of the things. But another way that you can do this, to show you how much it is flexible, you can define here list of apple, orange, cherry somewhere else, and I'm going to show you. For example, you put fruit and you put list. Okay, so now first I create this list. And now that I have this list, I can create another for loop based on this list that I have just created. But instead of X inside list apple, orange, cherry, I put just fruit. And for X in fruit, print this one. And I run it, and again, you see the same results. And the last structure that we have, the last syntax that we have regarding for loop is doing it through a vector. So please stop the video here, my friends, and do it on your own and check it with the demonstration that comes in a minute. Here we make for, here I put Y to notice, to show you there is no difference between the name you put here and C, 5, and 6. So here you cover the conditions according to schematic that we check together, and for that print Y. You see, we get everything. Now another things that we can do here to see, we can print that, and we are gonna develop our statement. See the interesting thing that happens here, my friend. You see, maybe some of you expected to see first 1, 2, 3, 4, 5, 6, and after that you see 6 times of hello world. But for loop doesn't work like that. See, what's happening here, it says for Y in this vector print Y, and after that print hello world, and after that go for the next Y. So what's happening here, it start Y in this, so it is 1. Print 1, hello 1. After that, 2, hello world. After that, 3, hello world. 4, hello world, and like that. Also, you can continue doing some calculations. For example, doing some calculations like Y times Y. So I run it, and you see the results. There is no result for Y by Y, but it has been calculated, but you didn't put any command for printing or anything like that. So we put print Y, and after that we get it run. And now you can see first it is 1, after that hello world, and after that a square of that. 2 hello world 4, 3 hello world 9, 4 hello world 16, and like that it continues. With loops, we can make much more sophisticated codes, especially that because of the huge power of computers in doing calculations and computations, being able to manage repetition is very important to make better codes. For loops are not the only way of handling the loops. But the other one that is very famous in programming is while loop that we are going to do in the next video.